Hello students. In this video, we are going to see how to represent a given relation. There are various ways of representing binary relations. However, we are going to see two of them. The first one is the matrix representation. Let's say you are given a relation R on the sets A and B. Then we have to first form a matrix in which the rows are labeled by the elements of set A and columns are labeled by the elements of set B. So in this matrix, the ijth entry will be 1 if the tuple aibj is present in the relation R. Otherwise, that entry will be marked as 0. So here, your resultant matrix will have the dimensions M cross N, where M is the cardinality of set A and N is the cardinality of set B. So this is how your resultant relation matrix will look like. So here, as you can see, the rows are labeled with the elements of set A and columns are represented by the elements of set B. If you see, this entry is 1. Why? Because in my resultant relation, the entry 1, A is present. That's why this particular entry is 1. However, this particular entry is 0. Why? Because the tuple 2, A is not present in my relation. So likewise, the relation matrix is formed. Now, let's see an example to understand how to represent a given relation using matrix. You are given two sets A and B and the relation R1. So I have to represent R1 in matrix form. So my resultant matrix MR1 will have the rows corresponding to the first set. So my first row will have 0, 1, 2, 3 and 4, and my columns will be 0, 1, 2 and 3. So this is my matrix. Now I'll have to populate the entries. So as you can see, in my relation R1, 0, 0 is an entry. So the cell corresponding to this entry will be marked as 1. Same for 1, 1, 2, 2 and 3, 3. Rest all other entries will be 0. So this is my resultant matrix MR1. This was an example in which the two sets were different. But what if the relation is on the same set? So in this case, the only difference will be that the rows and column elements will be the same. So now my rows will correspond to elements 1, 2, 3, 4, and columns will also correspond to the same 1, 2, 3, 4. Now I'll proceed in the same manner. So now 1, 1 is marked as 1. Same for 1, 2, 2, 3, 1, 3 and 4, 4. Rest all other entries will be marked as 0. This is the resultant relation matrix. Now, the second way. The second way of representing binary relations is the directed graph representation. So in order to represent a relation R on a set A cross B, first write down the elements of each set as nodes and then draw an arrow from each node X to node Y if X comma Y is a tuple in the relation R. The directed edge from AI to Bj will be present if AI comma Bj is an element of the relation R. So as you can see in the figure, the directed graph for a particular relation is shown. So let's understand with the help of an example how to represent a given relation using digraph. The same example as the previous one we are taking. Here A corresponds to 0, 1, 2, 3, 4 and B also corresponds to 0, 1, 2, 3. So even if the values are same, but the elements are different because they belong to different sets. So in order to not get confused between the elements, I'll label them as A0, A1, A2, A3 and A4. These are the nodes that correspond to the elements of set A. Similarly, for set B, I'll have B1, B2, B3 and B4. Now, I'll draw an arrow from one node to the other if that particular entry is there in the relation. So as you can see, 0, 0 is there in my relation. So I'll draw an arrow from A0 to B0. Then I will draw an arrow from A1 to B1. Similarly, I'll draw an arrow from A2 to B2 and A3 to B3. I'll just rewrite the labels A1 to B1, A2 to B2, A3 to B3. So here, this is the diagram for the relation R1. Similarly, if I have the relation on a same set, then I don't need different elements. I'll just take 1, 2, 3 and 4. So I'll draw an arrow from 1 to 1, 1 to 2, 2 to 3, 1 to 3 and 4 to 4. So this is the diagram for relation R. I hope you understood the graphical representation as well as the matrix representation for the graph.